Welcome back to Investing with Mackie. In this series, we're going to use ChatGPT to help us create a Python script to potentially predict market action. To get started, this first video is going to create a basic outline that we'll use to build on, hopefully creating a more and more accurate model in order to predict which direction the prices may go. So diving right in, here is the prompt I asked ChatGPT. I would like to create a Python script that uses machine learning to help predict if the SPY index fund will go up or down in the next 5 trading days. Can you help me code this script? ChatGPT gives this awesome overview of what it's going to do. And if you want to follow along more in depth and read through all the details, I've got a link to the chat in the comments below. But essentially, we have to collect our data. Then we need to do some feature engineering, which is deciding what the model is going to use in order to make its predictions. We have to prepare the data to make sure that the data can be understood inside of our model. We have to choose our model. So there's different machine learning models that we need to choose from. Then we train the model so it can use that data to make its predictions, evaluate the overall model, and then ultimately use this model to make predictions into the future. To get started, it recommends that we use Y-Finance. I've used it in the past, and this is essentially a library that pulls from Yahoo's historical market data. It's pretty legitimate, it's pretty easy to use, so I would recommend sticking with that. Then it dives right in and it tells us the code that we need to do. So we have a pretty big chunk of code here. In order to run this code, I recommend you use Jupyter Notebook. If you've never used it before, you can find some tutorials online on setting it up. It allows you to run Python script in a web browser, and you can essentially execute a little bit at a time, building out your code as you need to. So we can see here, it's got a copy code. So we'll go ahead and grab all the code and we'll paste it right in here. And then we can see what it's doing. So these are all the libraries it's importing. So it's going to use that Y-Finance library that we installed a minute ago using this library called Pandas. Then it uses sklearn, which is a group of machine learning libraries that can make a lot of this easy to accomplish. So first thing is we're going to go ahead and collect some data. So we'll grab the SPY symbol starting from January 1st, 2010 up until January 1st of 2023. Then this is the feature engineering. So there's a lot of different ways to do this, and we can actually ask ChatGPT for more recommendations, but essentially they're primarily using that moving average. So as the moving average goes up and down, does that mean we should invest or not? So they use a 10 period moving average, and since their data is daily, it's 10 days, and they use a 50 day or 50 trading period moving average. Then our target is what we're estimating on, and we can see that they're shifting that 5 days into the future. So we're basically determining whether the close price is greater than the price 5 days into the future. And if it is, we get a 1, meaning it's going up. And if it's not, we get a 0, which indicates the price should go down. We go ahead and prepare our data. So we have our X data and Y data. So X data is the data that's used to make the predictions. Y data is the data that the predictions, or basically the predictions themselves. Then we create this train test split. And what we're doing here is when you have your group of data, you want to break it up so that you can train the data, and then you also can evaluate the model. So we have our train X and our train Y, and then after it's trained, we can go ahead and evaluate using our X test to make predictions and see if they're correct based on the Y tests. The scaling features, this is important depending on how you're trying to manage your model and your data, but essentially because, say, SPY price goes from 200 to 500 over the last 10 years, it's not very well organized in order to make adjustments. So by scaling the data, it can make the machine learning model work a little bit better, and we'll look at addressing that in some future videos on ways we can make it so our model needs to be less concerned with scaling, and I think can ultimately perform a little bit better. Next, we create our model, and in this case, they're using a random forest classifier. So this basically is, it takes a look at all of the data, and then it says, hey, if this is greater than this or less than this, take this path. And ultimately it creates this branching tree that gets larger and larger until you get to the end. And you can accurately say, hey, if we follow this path, we think it's going to go up or we think it's going to go down. So it's going to automate all that for us. And the automation happens in this fit call right here. So we pass in our scaled data, both the training data or the training features and then our targets, and it'll determine what the model should make predictions based upon. Here we actually make those predictions, and then we go ahead and evaluate that accuracy. And we'll see that this will print that out here in a minute, and we can determine the accuracy of this model. This next part here allows you to predict in the future. So if you like this model and you want to use it, it can take that historical data and then pop out what the future models or future prices will actually be. So in Jupyter Notebook, to run the code, we'll just basically hit Shift Enter. We can see the code is running. It's being trained, and our model comes out with a 68% accuracy. That means our model is guessing whether the market goes up or down with a 68% accuracy. We can see here's the predictions using the last, I believe, 10-ish days going from April 14th. If we reset that and pick some different dates, we could see more predictions beyond that. But on April 14th, it looks like it predicted the price was going to go up. Okay. Now, this output right here is not super clear. So using some of my previous experience, we'll go ahead and go back to ChatGPT, and we'll ask it if it can give us a confusion matrix and a detailed classification report. ChatGPT comes back with, certainly. Then it modifies our script for us to be able to copy and paste right back into our Jupyter Notebook session. And then with this more detailed information, we can maybe see a little bit better how the model is performing. So we'll go ahead, grab that code. With the code pasted over here, we'll go ahead and run it. And we can see here this confusion matrix. And initially, these can be a little bit confusing, but essentially our top row is our downs, the bottom row is our ups, and then these are the predictions. So it predicts that it's going to go down 132 times. It is correct. 92 times it is incorrect. Okay, it predicts that it's going to go up, and it actually goes up because the bottom row is the ups 307 times, and actually goes down 111 times. So you can see here, it incorrectly says it's going to go up 111 times. Classification report gives us that information and easier to read. So 0 predictions are going down, as we discussed earlier, so 58%. And then going up, it's looking at an overall 78% precision. Recall and F1 score, you can look at those, but they're ways to optimize that information or average across the data to better handle false positives and false negatives. So here we can see off of our very basic model, we're getting a 68% accuracy. What we'll notice though is that 307 times it actually, or about 400 times it actually goes up, and 240-ish times it actually goes down, which means it's severely weighted in going up as compared to going down. So the model over time may learn, if I just predict it's going to go up, I'm more likely to be right. And that's what I plan to address in our next video, is how to handle the bias of the data to avoid having these predictions where it thinks it can just always go up and be more accurate. If there's other things that you think we should implement in terms of features like moving averages or other stock data to consider, go ahead and put that in the comments below, and we can try to interpret that or incorporate that into future videos. Thanks for watching.